Hello everyone and welcome back to another video. Shout out to Mr. J for this one. And what we have is a sequence. And this is probably one of the, I guess, easiest sequences to understand right off the bat. And it's just odd numbers. So 1, 3, 5, and then 7, 9, and all the way up to the nth odd number. And what I wanted to do in this video is just find out what the sum of what the first n odd numbers is. So to get started, what I'm actually going to do is draw a little table here and just write out how many odd numbers we have and see what their sum is. So getting started, if we have 1, the sum is just going to be 1. It's crazy. But then if we have, say, 1 plus 3, well, that's 4. And if we have 1 plus 3 plus 5, that's 9. And if we have 1 plus 3 plus 5 plus 7, that right there is going to be 16. And what you might notice here is that these are all right here are squares. I mean, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So you might think, there's no way that's a coincidence. And it's really not a coincidence. And essentially, this is what I wanted to prove in this video, that this right here is in fact equal to just n squared. So to get started, well, what we did is actually almost like the first step of induction. We proved our base case that one is 1 squared. Yeah, but we also did it for a few others, so I suppose it also applies. But now let's just do this for the nth odd number. So the way we can write this in, say, summation notation, is just going to be the sum from n equals 1 to big N, or these right here are the same, of 2n minus 1, and that's just every other number. So if you plug in 1, you get, if you make n 1, you get 1. If you make n 2, you're going to get 3, and so on, all the way up to the nth number. And what I'm saying, at least, is that this right here is equal to big N squared. And the way we can prove this is by essentially saying, okay, well, what's going to be the next term in the sequence? So essentially, if I add the next odd number to both sides, so if I just do a plus 2n plus 1, well, what we should get on the right side, what we would expect, is that it's going to be n plus 1 squared, because we're doing the next odd number. So yeah, let's see what this is. On the left hand side, we have our sum. So it is just going to be the sum from n equals 1 to n plus 1 now, of 2n minus 1. And then on the right hand side, we don't actually have this. This is what we want, so I'll kind of put it off to the side. But what we actually have is this n squared plus 2n plus 1. And you might be looking at this and being like, well, is that the same thing as n plus 1 squared? And it really is, because this right here is a perfect square, or we can factor it at least as such. And this right here is just n plus 1 squared. So because what we've essentially done is proven that if we add the next odd number to the sequence, what we end up getting is the next odd number squared, meaning that this right here is indeed the case. So I hope you all enjoyed this video. Kind of a short one, but I kind of like it that way, actually. So on that note, I'll end it here. Thank you all for watching, and I'll see you in the next one.